So obviously tonight is going to be our circuit and PCB design workshop, virtual workshop 3. Um, Tonight we're going to be covering not only just building out a circuit, but putting the parts and putting the traces onto a PCB. So there are going to be quite a few instances where I'm going to leave it open for discussion or open for questions for a couple of minutes because this is not an easy topic and this software is not intuitive. So everybody's going to be going at their own pace. I understand that. So if you need me to slow down, if you need me to stop for a couple of seconds and you're still trying to figure out some stuff, please let me know. Please speak up. Just unmute yourself. You don't need to raise your hand. You don't need to do whatever. We're we're all friends here. We're all in EECS together. And if you're not in EECS, I assume you're in a technical major, and it's hard for everybody, so I don't judge. Anyway, getting started, I have a couple of pictures up here. The one on the left is actually an image of the Arduino Uno that we used for last week's workshop. So you can see here a couple of instances where you have very, very small traces. So going around the controller that interfaces with the USB and the bigger microcontroller. And then some of the thicker traces on there, you'll see both in red and blue, are to power and ground. Usually you'd like to make those a little bit thicker just because you could have a bit more current going through them. But we'll cover all that here in a couple of minutes. And then of course I have the Eagle logo off to the right hand side, and that's going to be the program we're using. So Cole, still waiting for that to download and install?
All good.
All good?
Yep,
Perfect.
we're installed, signed in, and running.
Awesome. We'll keep going. So what is a PCB? This is Wikipedia's definition of a PCB, but just think of it as a carrier for all of the components and electrical signals in a circuit or device. It's in your smartphone, it's in your TV, it's in your Keurig. I know because I just broke mine. It's brand new and I just broke it and had to take it apart. It's in almost every electronic device that you use. Your LED light bulbs that you have little PCBs in them that hold the LEDs themselves and a little power circuit. So these things are ubiquitous. They are everywhere. You will see them if you crack open any piece of technology made within the last, I don't know, 50 years. So some of them are the standard green guys that you can see here. This is from a failed workshop from last year. And then we have others. This is an older one that Kevin had developed a couple of years ago. He was the projects chair a few years ago. But then we also have others that are actually more artistic. So they can have nice designs on them. They can also be functional in the placing of their traces. So you can have different parts of the PCB that you can touch and it will do different things. But for tonight, we're going the much more utilitarian view of a PCB, and it not only electrically binds the components together, but also mechanically binds them together. So, why PCBs and not breadboards or perf boards? Well, for one, breadboards are much more expensive. You have not only the plastic, but also the little pin holders on the inside, and there's a lot more production that goes into a breadboard. And breadboards don't really come in a lot of different sizes. Usually you only get them in 2 or 3 different sizes. And on here you'll see parasitics. So parasitics means that if you have a high frequency circuit, the little traces in there actually have a capacitance to them. And the traces on the inside of a breadboard are significantly larger than that of a perf board or a PCB, actually. So you can get a lot of feedback and a lot of noise by using a breadboard. And then also just they're one-sided. It's a 2-dimensional circuit, and I'll kind of explain what that means a little bit later on, but just keep 2-dimensional circuit in your head. You can only have things go one way. So the alternative number 2 is a perf board. So this requires a lot of planning because it is semi-permanent And actually on the underside of this perf board, what you would see is just lines of solder or wires running around. So this is not something that is as easy to manipulate as a breadboard. You're actually soldering the stuff in. Again, only one-sided, so it's a two-dimensional circuit essentially. And these are very hard to troubleshoot and repair. Like I said, they're semi-permanent, so you may not be able to get components back out very neatly. It might be a little bit hard to see in this image, but can you see the little ICs, the little chips, how they're actually sitting on something? It's like a little package. Let me see if I can get a better example here. They sit on these sockets because if you need to pull something out, I don't know, it might be a little bit hard to see. But if you need to pull one of these ICs out of a perf board and you don't have it sitting in a socket, you are probably going to rip the pins right out of it. So, moving on, some of the benefits of PCBs. They are cheap, and I mean like dirt cheap. For a 10 centimeter by 10 centimeter board, which is pretty significant, it's about 4 by 4 inches. It's only $2 for 5 of them through, I use JLC PCB. There are a bunch of different manufacturers. And these boards are two-sided, which means you can essentially have a circuit on one circuit on one side and another circuit on another side, and you can make them interact with each other. They can cross from one side to another if you want to get signals around. So these boards are actually three-dimensional circuits in a sense. And there's a way that Eagle represents that and other programs represent it. You'll see the blue and red. Let's go back, actually. So the blue and red traces on that PCB right there. The blue is for the bottom, red is for the top. That's an almost universal standard through all of these programs. Also, they're easy to scale up. So you can take one PCB and duplicate it hundreds of thousands of times, if not millions of times, and it's going to be almost identical. They're very easy to manufacture. They're also super compact, so you'll notice that this PCB is significantly smaller than a breadboard. These are a lot easier to adjust and troubleshoot because you're not always hard soldering stuff in. Usually the pieces can be removed if you apply like a heat gun on them. And also in the manufacturing process, they double check everything. They usually do a little bit of testing with like pins to see if there are shorts or any open circuits where they shouldn't be. And then of course, surface mount components, which is something that a lot of people might not have worked with before. And those are these pads that don't go all the way through the board. They're actually not holes. They're just pads of metal. You put solder on it, and then you put a device on top of that. So at this point, I'm going to open up the floor. Does anybody have any questions? The most boring part of this workshop, I can guarantee it. So, all right. And if there are no questions, no comments, I'm going to keep going. So how are we going to do this tonight? How are we going to get something from our minds onto a schematic and then put that onto a PCB? Well, first we have to create the schematic, which is essentially the components that we want to place on the board. For tonight, it's very easy. There are actually only 3 big components and then 8 smaller components. So 11 components total, and the 8 smaller ones are LEDs. So it's going to be duplicated. But it's going to be a pretty simple schematic, but I'm going to introduce you to a different way of doing it. Then we're going to convert this over to a board layout. Luckily, Eagle is pretty good about this. If you just want to create a new PCB, you just kind of click a button. You can have it auto place for you. I like placing the components myself. I can also auto route some of the signals and the traces between them. We're going to do that manually to start. But yeah, Eagle's pretty good about that sense. Now, moving the parts, obviously we don't just want a clump of components right in the middle of our board. We want to spread them out a little bit. So we're going to be moving those around, and I'll give you some tips and tricks on how to do that. And then we're going to want to wire them up. And again, PCB, usually most PCB software has some guides on how to do that, but there are, again, tips and tricks and actually some pretty solid rules that we're going to need to follow. So it's at this time where I'm going to give everybody a couple of minutes to get the software open. I'm going to post a download link. I'm going to stop sharing my screen. I'm going to post a download link to a couple of files that you're going to need. And we're going to go through the process of setting up Eagle to work on this project. Sound good? Everyone's real quiet. This is not a lecture, guys. This is a workshop. You're allowed to talk.
Sounds good.
Thank you, Rebecca.
Sorry, Ethan, this math got me real quiet right now.
That's fine. I understand. Everybody else, though, there's no excuse. All right. So I'm going to go ahead and post this link. It's going to be a zip folder. Link. There we go. So it's the most recent one that I posted. I know I had posted a couple of links in here. But the most recent one should take you to a zip folder. It says IEEE Workshop 3. Go ahead and download that and unzip it. There are going to be some subfolders. Looks like there are extra files in there that I did not intend to be in there. But should be fine. So just give me a thumbs up whenever you guys have that downloaded. Should only take a couple seconds. It's not very big. Okay, sweet. Got a couple of thumbs up. Yeah, there we go. All good. Sweet. All right. So I'm going to go ahead and I'm going to share my whole screen right now. Let me know if it's a little bit small. I think there are some things. I'm actually going to increase the size of some objects within Windows. But just there might be some things that are really small. So if there's something you can't see or if you're watching on a phone, let me know. Let me go ahead to 125. There we go. All right. Can everybody see my screen? Yes, no?
I don't think you're
No.
sure. Oh, it's loading now.
Oh,
Okay.
Yes.
It might
I
have just
see it.
taken a second. Okay. And you guys don't see the image of like the people, right? You don't see the zoom?
Nope.
Perfect. This is always so sketchy to do. So you're going to see this kind of intro screen. It's probably small for you guys. I know my icons are messed up in the background. But you're probably going to just see this screen. Go ahead and maximize it. And we're going to start by creating a new project. So just go to File, New. I can do this, and then Project. So you'll see on the side, it'll open up like a projects folder, and then it'll ask you to type something in. So I'm just going to do Workshop 3. I'm going to call mine Demo. Just call yours Workshop 3. I already have a Workshop 3 in here, so that's what I'm going to be using. And then once you do that, you'll actually see, if you kind of click out or click away, that there's a green circle to the right of where you've named that project. Does everybody see that? So all that means is that this is the active project right now. And you can have multiple projects active at the same time, but just for the time being, we're going to only work with one. So go ahead and in that Workshop 3 demo, whatever you called it, go ahead and right click it and hit New Schematic. And it should pull up this window. It should be a big blank screen and then some stuff off to the left-hand side. I see some confused looks. Everybody good? All right. Are there any questions so far? Nope. Okay. This is the easy part so far. So then you'll see this big blank screen. If you go ahead and click a few times, you might be able to draw some nice shapes. You can always hit Escape at any time to take you out of whatever selection you're in. And that usually goes for all of the Autodesk software. if you've gotten into something and you don't know what's going on, usually escape is the best key to press. It just gets you out of that trouble. So we obviously need to know what schematic we're going to be building. I'm going to go ahead and pull this back up. I'm going to present this. You guys can see the schematic here, right? Okay. So this is going to be the schematic that we're building. Like I said, there are three main big components, and then you have a few smaller ones. So this is actually going to be a microcontroller circuit. Very basic, very simple. So we're going to have the microcontroller up here. It's just this big red box at the top. You see there's signals coming out from either side. We're going to have a shift register. You don't need to know what it does. You don't need to know what it is. Just know that it's going to be a part of our circuit. And that's down here. And again, you see some of the same names, like there's this GND for ground. You'll see it in 3, or actually 4 different places on here. Then next up, you're going to see this little connector off to the side. That's just to be able to get in power and then a signal to program. And then you have this bank of LEDs right there. Oops. So we're going to go step by step. I'm going to leave this schematic up for you. Also in the folder, you will see that there is a schematic file it'll say like workshop 3 for reference, or whatever, schematic for reference. But before we start this, we need to make sure that we have the right libraries installed to get these parts. Usually the parts that come with Eagle are very industrial, or they're very generic. But we're looking for 3 specific things. So I'm going to go ahead out of that. Go ahead and minimize it. And you'll see a tab up on the upper left-hand side that says Library. And go ahead and hit Open Library Manager. Might take a second to say fetching library updates. Just go ahead and let that load. But then you'll also see in use and available. So the in use ones are the ones you're going to have downloaded. You may see some of the same ones that I have here. But it's a big long list. And it might say that some have updates available. You don't need to worry about updating stuff right now because we're going to be using specific libraries. Hold on, I'm just pulling up something on my laptop here. Any questions so far? Solid. I know some of you are like, when are we actually going to get to the fun stuff? We'll get there. Okay, so one of the first libraries that you're going to need is actually by SparkFun. So in available, go ahead and scroll down until you get to all the SparkFun things. You're going to see like amplifiers, comms, conversion, memory, LEDs. There's going to be a whole bunch of stuff there. So first and foremost, you're going to need one that says SparkFun-IC-Logic. So go ahead, all you need to do is click on something. I've already downloaded it, but you just click on it and then click the Use button. It'll download it, it'll load it up into your current project. It takes care of that all for you. So then the next one is SparkFun-LED. Just some generic LEDs. It also has some RGB stuff and like different sizes of LEDs, different shapes and stuff like that. And then finally for the SparkFun ones, do the one that says SparkFun connectors. I'm just gonna make sure I have these, yeah. And this actually has just about every connector that you could imagine, except for USB. Unfortunately, those are in a different category. But for right now, that should be enough to get you started. We also have one more library that we're going to need, and it's the one to use the microcontroller that we're going to have in our design tonight. But that is not built in with any of these available libraries. So we're going to be making our own. And it's very easy. I'm going to show you how to do it when you get a part library from the manufacturer or from a third-party distributor. Usually, if you go on a website like DigiKey, they'll have like a link down below. It'll say like overview, data sheet, and then one of them will be schematic files or schematic footprint, something along those lines. So go ahead and navigate into that IEEE Workshop 3 folder. You'll also see like another .dxf file. You can delete that. It's garbage. But go ahead and go into the library guide folder. So I do have an ATtiny 412 library file in there. Don't worry about that. That's only in case of emergencies. I'm going to show you how to build these yourselves. So you'll see this SCR script. Does anybody have this script file and it doesn't show as an Eagle configuration script? Because there are some instances of it not playing very nice with some programming languages. So I just want to make sure everybody, it says Eagle configuration script, head nods, blank stares. Okay, good. All right. So we're going to go ahead and just minimize out of that. Make sure that's on your desktop or somewhere where you know it's at, even if it's just in your downloads folder. But we're going to go up here to File, and then New. Oops. Not that. We want to go back to the main control panel here. So this main file here. Not the schematic one. And so go ahead and right click on that project folder that you had and do New Library. You see a window pop up like this. Everybody have a window pop up like that? Yes. Head nods. Okay. The thumbs up are always appreciated. Okay. So in this, sometimes you'll just get library files for Eagle. Sometimes, though, you'll get these scripts, which you would have a very hard time deciphering them because most professionals don't know how to decipher them. They're just automatically generated. There's usually a program or an algorithm that's run on the website that you're downloading them from that pieces it together in the right format for Eagle or KiCad or Altium. I don't know if it's KiCad or KiCad. It's pronounced different ways. But we're going to go in here and we're going to do File, Execute Script. And then go ahead and hit Browse. And then just find wherever that script was. So mine is on the desktop, IEEE Workshop 3, Library Guide, and this library script file. I'm just going to go ahead and hit Open. And you'll notice that your computer might lag for a second, and then it goes and generates this. Does it look about right for everybody? Sweet. So all you need to do is hit the Save button. And so I named mine just ATtiny 412. That's the only part that's in this library. Most libraries will have more than one part, but just for this workshop, I wanted to show you guys how you can do this with one part. You can also add parts to this as well. If you have multiple script files that you have or multiple part configurations, you can add them all to the library as different devices. You'll also see that there are different footprints for it. So this is just for different production runs of the part. We don't really need that right now. We just want this first one up here. So once you have that saved, yeah, what's your question?
So what if you want a different device? How would you like find that? Like you provided us with that library file. That
is a great question. So let me go ahead in here and do ATtiny 1624. All right. And then I'm going to go to DigiKey for this one. This might not be a great great example because this is a very new part. So actually, I'm just going to go back to the ATtiny 412. So there's a page for this. And then if you come down here, you can look at EDA/CAD models.
Okay.
So it'll do ATtiny 412 SSNR. That's the part number and then the package type by Ultra Librarian, which Ultra Librarian in itself is a great resource. But you see how it kind of generates all this stuff for you. So all you have to do is hit download now. I'm already signed in, but it has tons of different types that you can download. So there's just a regular 3D CAD model. If you are designing like a case or a heatsink and you need to make sure that it fits, you have that. Altium, Autodesk, obviously Eagle, KiCad was another one that I had mentioned. All the rest of these, I have no idea what they are, but we don't need to know that. So Eagle, all you do is check that and then log in to download. It's free. They just want to make sure they're keeping a record of what you download. So that's how you're going to get it. And again, this provides you with the script file. Some of them will be nice enough to just provide them with your own library. I've had instances of DigiKey just providing like a straight up library file to drag and drop into the libraries folder. But we can cover that later if you guys have questions. Anybody else have a question about this process?
Just a quick one, not necessarily about the process itself, but for example, if we wanted to get it for multi-board or like multi-sim,
Yeah,
is
so
that common to find or is it from within?
so multi-sim and AltaBoard are difficult because they are not industry standards. They were years ago, but I would say if that's what you're using, it's going to be a little bit difficult to find accurate parts for them. Usually the packages that like the 210 professors provide, that's all built in to multisim and AltaBoard.
Yeah, that's good to know. Thank you.
Okay. Colleen, I got your message. Thanks. Maybe you and I can meet later on this week or maybe this weekend or something, and we can get it up and running. This is recorded, by the way, so if you ever need to come back to this.
Okay. Yeah, I don't know. I couldn't open it. I just keep clicking on the icon and it's like it shows me, hey, I'm opening, and then whoop, it goes away. So
Dang it. Okay. Try opening it as administrator. If that doesn't work, like I said, we can always come back to it.
that works. Thanks.
Yeah.
You
Okay.
could also see if like in like your task manager, it shows that it's running and you can try and like manually end the process.
Yeah, that's another thing too.
Or like if you want to try and do that through the command line, you can do that too. And then maybe try again. Because I had that issue with, like, I know this is really random, but I had that issue with Discord where I'd keep trying to open Discord and it just wouldn't open. And so I looked it up and I had to go into the to my command line and run a quick command to end the process and then open it again, and it opened just fine. So that could be your issue.
Alternatively, you could just restart.
Yeah, exactly.
Restarting fixes most things.
Well, I tried already. Unfortunately.
Oh, dang it. Okay. All right. Well, yeah, we can take a look at that later this week, but still stick around because this is a lot of good information. And when you do get it working, it'll be useful to already know all this stuff. So once you have, back to the library thing, once you have it saved, go ahead and you can just X out. It's already added, and you'll see it actually under here, this attiny412.lbr. You can see all the footprints and the symbols, and you can explore all that. But we'll go ahead and minimize this control panel. Do not X out because the control panel actually needs to be open the whole entire time while you're using Eagle. We'll call it a quirk instead of a annoying feature. But now if we go ahead back into that library manager, while it's updating here. Let's go. Oh wait, maybe it's already in use. Yeah. So if you go to the in use, can you guys find the ATtiny 412 library? Sometimes it doesn't add automatically, so you might have to add it yourself. Does anybody not?
Do we not have to click use on the control panel in order for it to show up?
Yeah, it should automatically be added. If you see use, was there something on there that you saw that said use?
Well, no, I just saw that there wasn't a green circle because I remember like a green circle should show up if it's like in use, right?
Yes and no. So actually, if the project is active, it should be in use. There are a couple different ways that we can get around this. Let me go ahead and check with some other people. Jackie, are you able to see it in your in-use section in the library manager?
I don't see it.
You don't see it? Okay, so go to available. And then in the search for library name, just type in AT. Usually it should pop up. You guys seeing it? No. Guys got to make this difficult for me. Okay.
I had to go back and like on the project window, click it so the circle was green.
Okay. Maybe it's just because I already had it active.
And it showed up in my in use. Yeah. See, but yours isn't green.
There. I just clicked the circle.
Yeah. But it was showing yours without that being green, right?
I think I have it installed in a different way because whenever I was setting this up, I had it separate. All right, let me go ahead and open the schematic here. So if you guys click the green circle, do you then see it in your in use? Click the little circle to make it green. Go ahead and look down. Head nods. Good. Also checking in with those who don't have their cameras on. Jeffrey, Jack, Willem, Con, Andrew, Daniel. You guys all good?
I'm all good.
Okay. Yeah, I just want to make sure you guys are okay. You good, Con?
Yep.
Okay.
Everything's working for me so far, so yeah.
Nice. All right, I didn't want you guys to be left behind if I'm going a little bit too fast. So you do now all see it in your in use, which is very good. And now I have two. All right, whatever. They're identical. But we're going to close that, and then we're going to add our first part to the schematic. This is exciting stuff. Go ahead over here. There should be a little plus, and then it looks like a plug, like a wall plug. That's just your add part. And you're going to kind of see something that comes up like the library manager, except it has all the libraries there, and you can open them up. So I'm going to go ahead and open up the ATtiny thing over here. And we want the one that's just the ATtiny 412 SSNR. None of the junk at the end, just that one. Can everybody see that? Sweet. Go ahead and click OK. And you should have this thing floating around on your mouse. Whenever you click it down, it'll auto-populate some of the explanation there, and then go ahead and hit escape once to get back to the part selector, escape twice to get out of that. Sound good? All right, cool. So after I do this and kind of explain some of the nets, I'm going to let you guys go off on your own for about 5 or 10 minutes to figure this out, because this is just the schematic building. We're not actually physically building the PCB yet. This is just the schematic, just so you guys know that. There are no parts right now on a board floating somewhere virtually. This is just a 2D representation of things. So one of the other really important tools is just this net button. You'll see it's a green... What's that?
Could you maybe go back to placing it
Yeah, of course.
Okay, thank you.
Can you guys see, are these icons really small on the computer here?
It's more, mine's just like, instead it's like a popped out window instead of like a side window. Mine's like its own popped out window.
Oh, you can actually click and drag stuff off to the side and it should snap there.
Okay.
Is that working for you?
I don't know why. It's like doing the like snapping wherever it makes it half the screen instead.
Oh, that's weird. You might be able to resize it. I can usually resize some of my stuff too. But yeah, you just click that add part button. Like I said, it's a plus and a little plug. It should be right next to the plus on the Lego block. And then you can find it from there. Is that working for you?
Yeah, I found it now.
Okay. So going back to this net tool, it's a little sideways L that's green, not blue. It's green. You'll notice that it doesn't change your cursor or anything whenever you click on it. It just highlights that button. I wish there was a better representation for this, but there's not. You can go ahead and use your scroll wheel to zoom in. We're going to be looking at this pin 8 over here. So this works very similar to multisim, just kind of draws a line. So I'm going to draw it over 1, oops, and then kind of up like this, just so we can kind of have this out. And you can do that for the others. And this is really only visually to space things out. So go ahead and give me some head nods, thumbs up, whenever you guys have that finished.
There.
How do you delete a line?
So you can right click on it and hit delete, or there's a delete button off to the side. I believe also you can just select a line and press delete. Yeah. Again, it's not the most intuitive interface, but if you can do this, you can work with just about any program.
Is there a specific way to finish a line?
Yeah, so go ahead and just click again at the point that you want it to end.
It just keeps deleting it.
It keeps deleting it.
Yeah.
Interesting.
I don't know if you heard that, but it makes like this noise when I click the second time.
That's interesting. Are you using the net one, the green lines?
Maybe not.
Okay, because there's a blue one that's a bus, and that's more for like data connections. The green one is just for regular electrical signals.
Oh, okay, I got it. I see it. Thanks.
Okay. I was gonna say I'm kind of jealous. Mine doesn't make noises whenever it gets deleted. I want the fancy noises. Okay. So once you have this done, kind of arranged in like a spider, we're gonna do the same on the other side, but just starting on the right-hand side for now. We're gonna go over to this name tool. And it's the one that has R2, and there's a line, and then grayed out it says 10K underneath. So go ahead and click that. Click name. Again, that button should highlight. Nothing changes on your cursor. But then we're going to go over here, and we're just going to click this line. So this little name box should pop up. Everybody see the little box? Awesome. Okay. So this is your introduction to nets. So think of nets as almost like a variable where if you're connected to that net, you can see that value. So right here, we're going to be typing in GND. So it should only be able to do capital letters, but just GND for ground. Click OK. And go ahead and place it like right above here. You can hold Alt to more precisely move it while you're moving your cursor around. Just makes it look nicer. Everybody see that? Sweet. Then we're just going to do that 3 more times. We're not going to do ground. We're actually going to be naming it something else. So just make sure you have that name tool selected. On the second line, we're going to call this clock, or just CLK. And again, you don't really have to understand how this circuit functions. This is more to show you the concepts of the program. The next one down is going to be RST for reset. And the one on the bottom is going to be called latch, L-A-T-C-H. So, everybody done with that? That's not bad. That's an easy step right there. So on the other side, go ahead and do the same thing. I'll give you a couple of seconds to draw the lines. Any questions while we're on this, by the way? Also, Control-Z acts like it does in any other program. So if you do something or you want to go back, just Control-Z. You want to exit out of a tool, hit Escape. So I'll go ahead and zoom in here so you can see what I'm doing. Top one's going to be VDD. The next one is going to be PA6. You can see this kind of follows a trend from what it says over here as well. You'll see that just doing the PA6, PA7. And that just stands for addressable pins. They can be used as analog. Again, you don't need to understand how this works. But for those of you that are curious, I figure I can explain a little bit. And then this last one is going to be data. Guys, good with that? Looks like a really wide spider, chunky spider. Again, this is Halloween themed. Come on, guys. Is anybody else here like a huge Halloween fan or just like a fall fan? I don't know. There's something about it that's just like, it's just fun. I heartily enjoy it. And the weather is usually pretty nice until it's rainy. For the 4 months of the year in State College, that's just straight rain, freezing rain.
See, the problem with fall in State College is we go from 80 degrees to 30 degrees in like a week.
Yeah, it's not the most optimal situation. I like the rest of Pennsylvania fall where it usually gets down to like 50s and 60s for a few weeks and then it starts freezing.
And
State
it's like
College,
80 mile per hour winds every day.
Yeah, well.
Always windy here.
I don't know if I'm weird, but give me like the 2 select weeks per year that are like 40 degrees and like the leaves are like almost all off the trees. I like that weather the best.
Nah, I really like the fall colors. Like just driving through the country, especially around here when it's kind of hilly.
Yeah.
On top of one of the hills and you just see out and it's just like a sea of color. That's what I like.
Absolutely.
So, all right. Has everybody gotten this far in the process? I know it's only taken us an hour, but don't worry. The rest of it's going to go pretty quick. It's not bad. So we're going to place two more big items and then a few LEDs. And then I'm going to let you guys go ahead and finish out the circuit from there. So go ahead to add part. And then the next one is going to be all the way down in the SparkFun IC logic. Let me just make sure I know which one we're getting here. All right. So in that category, it's going to be this 74 star 595 drop down. And it's going to be the one that ends with an N. So it's just like a regular IC chip through hole kind of package here. Let's go ahead and hit OK. Plop that down. And then hit escape to go back to this menu. We go ahead and minimize the logic. And then we're going to go up to connectors. This one's going to be in the CONN_03. And it's the part of the same name. Just go ahead and hit OK. You can also right click to rotate things whenever you're placing them down. So just for the sake of this schematic, go ahead and just place it in there. Pins facing towards the left. And then the last one's going to be fun. Go ahead to the SparkFun LED. Navigate down to just the generic LEDs and select the 5mm LED. Go ahead and hit OK. Rotate them so they are pointing to the right. So you'll see the little arrows are going to be down underneath it, pointing down diagonally to the right. And then go ahead, you can space these out a little bit if you want. We're going to do 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. I can count. Hit escape twice, and you should be back to this. So you'll see that all of these are also numbered. Each one of these parts has a number. So like this is U1, and this is U2. That's usually standard for logic chips. If you are familiar with the EE210 amplifier circuits that you build, you'll notice that it'll say like U1A, U1B, because a couple of those amplifiers for the op-amp chips, they have 2 op-amps on one chip. So that's kind of the designation that the programs give these chips. And then from here, I'm actually going to flip back to the PowerPoint. It's probably going to be easiest. And I'm going to let you guys build out. What's that?
Sorry, how do you move a part?
Great question. There is a move tool. Now, I wish that you could just click something and drag it because that is just intuitive. But the move tool is this little arrow thing over here. Go ahead and just click and drag a part around. You can also do the same for the net lines. But yeah, and it will snap to a little bit of a grid, you'll notice. It's a blessing and a curse.
I'm not able to move it.
It feels like the diodes just move when you click on them. You don't have to click the move tool.
If you have the select tool enabled, you can also move them.
Yeah, so I click the move tool and I get that annoying ass, like when your computer like does the do thing. You know what I'm talking about?
Interesting. Hit escape. See if maybe you're already selected into something.
You have to click the like the plus sign that shows up on each of the parts.
Yep, should have mentioned that. There's usually a plus sign somewhere hidden on all of these parts. So for the diodes, for LEDs, I should say, it's right here at that junction. You can click.
Oh, okay.
Yeah. Again, it's a quirk. It's not an annoying feature at all. For the AT Tiny up here, it's actually way off to the left. You'll see it kind of in this elbow right there. That's why we placed that one first, because it's incredibly annoying to move. And that can usually be changed going into the library and editing the part, but that's a completely different topic.
So how do you move the wires with it? Like if you go to move that big piece, the wires don't.
The wires don't really move.
You would have to move all the wires individually, I guess.
You mean like that?
Yeah.
Yeah.
Like you can't highlight a whole piece and just move it?
Yeah, so if you go up here to the select, or it'll say group.
Yeah.
You can click and drag. And then I believe it's right click. Oh, wait, yeah, move. Hold on. I have to select the whole thing. Again, this is just one of those working with the software kind of things. Have the move tool selected. And then right click the whole group. New group.
Wait, so you had the move tool selected, right click.
Basically,
What?
try not to move. Try not to
Group.
move more than one thing. I know it's hard.
I put it like super low down on the page.
Okay, that's fine. So what I had
just
to
tried to
do
move it.
actually is I selected everything. I hit right click, add to group, and then back at the move tool, you can right click any piece in this. And you get a little move group icon.
Can
see
you
how this-
add other things to the group after the fact, or can you remove the group easily?
You can, yes.
Okay, because I was gonna say if they don't allow that, it's gonna be very counterintuitive. It already is to me.
Yep. Yeah.
Wait,
So
so
you
I
can.
grouped it, but how do you move the whole group?
So just go to the move tool, and then right click on anything in that group, and you'll see like move group. You have to have it selected, but
Oh, okay, cool. Thank you.
so yeah. In any case, I was gonna let you guys build out this circuit, but I think that would be a little bit boring. I would rather have you guys get to the PCB design stuff because I think that's a lot more fun. So go ahead and open up that folder that I'd given you. Go ahead and back up to the W3 schematic for reference. And then in here, I kind of gave you a little cheat sheet. It has the schematic already built for you. But I'm going to open this up just so I can kind of show this to you. If you want to build the circuit on your own, you're more than welcome to. You have all the tools at your disposal now. But I want to show you how nets work really quick. Is everybody able to open that up? Is that a yes?
Yeah.
Okay. Sweet. So you'll see in a couple of different places on the schematic that I provided for you that you'll see like ground is named on one, ground is named on another, VDD is named in a couple of places. Those lines, those nets are actually linked as soon as you name them. So for instance, if I click on this and I like make a new name for it, it'll say, do you want to connect VDD and this net? Click yes, and that'll electronically link them together. So although you don't see it on this page, it will be connected whenever we go to design the PCB.
Is there a shortcut for the add the name button?
There are shortcuts for all of these, but it's like Control plus T, Control plus N. For me, I just click the buttons. I wish there was an easier shortcut. There's also this command line up here that just switches tools. Like if you type in N, it'll automatically populate with name, and you hit enter and it switches to the name tool. Again, not intuitive whatsoever, but it's the program we have to work with.
Can you repeat what you did with the nets? Or what you showed?
Yeah. So if I create, say, a new net, not really connected to anything, it's just there. You'll notice that whenever we named the other ones, it didn't prompt you for anything other than just the name. And it kind of had a default. It was like N $17 or N $ something. If you go down to the name tool, and I'm just going to click on this blank net that I did. So this is N $1. If I want to connect this to ground, just GND, I hit OK. It's going to say, hey, warning, there's already a ground net that you have established. Do you really want to connect this? So yes, I know that I want to connect this to the ground. This component needs to be grounded. This pin needs to be grounded. Does that answer your question?
Yeah.
Okay. So I just say yes, and it gives me this little ground logo. Obviously, though, it's not going to anything, so it's get rid of it. So I would highly suggest going to the group tool, selecting everything. And actually, you can just copy it and then go into this that's selected, and you can paste it. So I know we just did everything. I just wanted to show you how to place components, but I think it'd be a lot faster if you just place things down. So whenever you're ready, I'd say go ahead and do that. Like I'm just going to delete everything and then paste this in. So yeah. You guys cool with skipping the circuit building part and getting to the PCB design? All right. Does everybody have any questions? Everybody cool with this? Those in the back without the webcams on, how we doing?
All is going well for me.
Good to hear. Got thumbs up. Okay, thumbs up. There we go. So once we have this circuit here, we want to save it. We don't want to mess with it too much because this circuit works. So you're going to just hit, I'm just using Control S to save. It's going to bring up this window for you. I'm just going to name mine Workshop 3. If I spell workshop right. Demo. And then I'll add the .sch at the end. You can actually open .sch files in any EDA program. So any program that allows you to edit schematics and design PCBs and stuff. I believe even the Multisim program allows you to open schematic files. It's not native, but it allows you to open them. Just go ahead and save it. And then you'll notice if you go back into the control panel, you'll see it underneath your Workshop 3 project folder. And it gives you a nice little preview there. Everybody cool with this? All right. So we're going to move on to creating the actual PCB. Before I do that, though, I believe there is a slide that I wanted to show you.
Wait, I'm super annoying. I had another question.
What's your question?
So in the one chip, you have ground 13 and ground. What's the difference?
Okay, so the 13 is the pin number.
Oh, you didn't name it ground 13.
No, you'll notice
Okay.
they're a little bit different fonts.
Oh, I see. Okay, okay.
Yeah, that's just because it's so close to the naming of the chip.
Okay. I was like, what's ground 13? I didn't know there were different grounds.
Yeah, no, but that
Okay.
is actually a great thing to bring up because if you have somebody else, like a lot of you, who are reading a workshop or a schematic that I designed, if you can't understand what my schematic does, it's completely pointless for you to have it. It's worthless to you. So like that's bad on me because this should be very simple and easy to read. There are also ways to put text on here. So there's like this little text button. So I just hit enter. I can place like hi on here, or I can point to something and say, you know, this ground is separate. Like I can have a ground 1 and a ground 2. If you have signals that might conflict or anything like that, and you can explain like, hey, this is what this does. So yeah, that's actually, I'm glad that you brought that up because that is seriously an issue. I have opened up several schematic files that I found on GitHub and stuff that are completely unreadable. You just have no idea what's going on. It's a mess of wires, stuff overlaps. So yeah, that's actually really good to bring up. Any other questions? All right, sweet. So we go and present this. Some rules. And these are, the first two are hard rules, actually. The third one is just more of a signal integrity, avoiding conflicts with signals, stuff like that. But the first one, it is best practice to avoid 90-degree angles. So 90-degree angles cause a lot of issues, but normally only when you get up to high frequencies. If you're dealing with signals with high frequencies. If you're just using, say like a power line or a ground line, you can have a pretty safe 90-degree angle if you're not using these super high currents or anything like that.
Or you might
I was going
melt
to
your
say,
board down.
what's the question?
I was gonna say, or you might burn your board down if you put 90 degrees.
Yeah, I mean, I would hope that there aren't any boards that would just catch fire at 90-degree angles. But think of it as like a flow of electrons. Think of like a flow of electrons as like a flow of like water, basically. If you have electrons going one way really, really fast, typically you want to avoid sharp angles. You want to do something rounded or do a couple of 45-degree angles. It's best to do that because you're going to get a better flow of electrons. Also, there are different sizes for these traces that we're going to be putting down on a PCB. I'm going to show you how to set those in a second, but typically for applications that are above 5 volts, you want to have them at a certain size. We're actually not above 5 volts for this circuit. The circuit's going to operate at 3.3. So we can have some smaller sizes for that. It's not going to use too much power. Also, you cannot intersect 2 wires on the same side of the board. You know how I said 2D versus 3D circuits earlier? This is one of those instances where you kind of have to have a 3D circuit if you want to compact everything down to a certain area and you still want all of the signals to not overlap. Again, there's a top plane, which you can have a completely independent circuit from the bottom plane, or they can interact with each other any way you choose. But if I have a ground trace and a 5-volt trace going across the top of a board and they intersect, well, it's not 2 separate traces anymore. It's just one piece of copper. You're going to short it out. You're going to burn up a battery. You're going to fry some components. It's not a fun time. Everybody's done it. So, you live and you learn. But the third one is more of a recommendation. Try to keep the wires spaced apart. Just allows you for a little bit more room, helps you not only organize your mind, but also organize the flow of your traces on a board. Typically, you want a little bit more than a trace width between 2 traces. And the auto router program is pretty good at doing that. But if we're manually routing these, it's going to need a little bit of TLC. Okay. Any questions on that? Okay, I want to move on to the fun stuff. Again, it's only taken us over an hour. So here's the most fun button in this whole entire program. This generate/switch to board. Go ahead and click that. It's going to ask you if you want to create a board from the schematic. Hit yes. And it should pop up with something looking like this. So this is actually way, way, way too big for what we're going to be working with. Go ahead and just click and drag to select this whole entire thing. And you can hit delete. This is where the fun part comes in. We're going to set up a couple of tools and options. So go ahead up to edit here. And then go down to design rules. Go to sizes. And you're going to see this minimum width category. So everybody is say 6 in there.
Sorry, can you repeat how you got there?
Yeah, of course. I'm just going to close out of that. Edit. Go all the way to the bottom to design rules. Click that. And we're going to go to sizes. Does everybody see the 6 mil in the top category? Okay, go ahead and change that to 10. Hit apply, and then hit OK. Should close that window. So that just beefs up the size of the tiny little wires or traces that are going to be on the PCB. So we're going to need some outlines for our PCB. You can very easily use this line tool select the dimension, which should be yellow, up here in this little layer drop down. And you can draw a nice rectangular PCB. Mine is not 100%. There we go. And you'll see once you have an enclosed region, everything else will kind of gray out and the black area will just be in that little box. Ready to do that real quick?
Can you repeat what tool we're using to do that again?
Yeah, so down here on the left-hand side, there's a little line tool. It should be a diagonal line. And then make sure you have the dimension layer selected up here. So anything in the dimension layer is just going to be the physical dimension of the PCB. You'll also see a top and bottom. We're not going to use those right now. So just dimension, and then go ahead and draw out something nice. Be a wacky little shape. Oops. There, I just did that goofy little shape. It's a very unhelpful shape. So you guys see how it's enclosed? I'll go back to this. Now we can start dragging components onto this. Don't do this right now because there's something that we're going to do in a second, but I just want to show you how you do this. Go ahead and click the move. And as Jackie had pointed out earlier, there's a little like a plus in the middle of almost every single one of these components. That's what you're going to want to click on to drag stuff around. So you can obviously just drag it onto the breadboard, or not the breadboard, but the PCB that you have. You can just drag everything over, make sure it doesn't overlap. This one's a little finicky. The connector has it on the far left here. But anyway, you can see how you can just drag everything over, place it anywhere you want. Obviously, you don't just want to place it willy-nilly. You want to make it look nice. So instead of messing around with just this square, this rectangle, I prepared some nice little shapes for you guys that are fall themed. Go ahead and open up that folder again that I sent, I know, and go to the SVG and DXF files. So you'll see a lot of stuff in there. My naming scheme is a little bit off, but you have a bat, you have a ghost, you have a leaf, and you have a pumpkin. So some fall themed shapes, and I'll show you guys how to import those in just a second. So have something in mind that you want to select. Also, we'll get to this in a second, but there's like little config pictures, and it just shows you what the scale is that's appropriate for these, because we want to keep these PCBs under a certain size. Just going to be easier to order. So go ahead and minimize that window. I'm just going to Control-Z all this stuff back to where it came from. I'm going to select this dimension, get rid of it. So you guys should be seeing a black screen. So everybody get back to this black screen that you have. All right, what do you guys want the demo shape to be?
Pumpkin.
Can't imagine who said that. Okay. All right, we're going to do a pumpkin to start off. You guys are more than welcome to select any shape that you want, but I guess I'm going to be doing a pumpkin. So we're going to go up here to File.
Well, I just want to see what it looks like first.
Okay, well, that's fair. We're going to go to File, go down to Import, and then you'll see a little DXF extension here. Go ahead and click on that. Luckily, I already have the pumpkin selected in here. I was kind of prepping for that. Does everybody get to this point? You see the DXF import -2.0. Yep. Thumbs up. All right, sweet. So there are a couple of different settings that we want. The target layer we're going to set to 20, which is the dimension. You'll see that there are actually a lot of different layers. There are 255 of them, in fact. the dimension is pretty standard 20 across the board for all of our EDA programs. When I say EDA programs, I mean anything that's going to create a schematic or a PCB design. So target layer is dimension. The X origin, Y origin, don't have to mess with those too much. The width is just going to be like the width of the line that we're drawing, but it handles that all whenever we're importing this DXF file. So the most important thing is going to be scale. Like I said, in this folder, there are going to be these config pictures. I literally just took a snip of each of the config things. So like the pumpkin one, I just have a scale of 0.02. It just works well, and it gives you a pretty good size. But for example, like the bat, 0.03 is the one that I went with. And I actually ordered some PCBs to prototype, but it's running a little bit late, as usual. So I'll go in here, click OK. It's going to pop up with another window that says Run Script. What it does is it translates the outline of this image. Hold on, there's a chat. Let me see. Can I have one to solder? Of course you can. So it's going to generate a script that actually draws a bunch of little lines around the outside. Sorry, was there a question? Okay. So go ahead and just run this script, and you'll see what it does. Just draws it out. Get a nice little pumpkin shape. People can get a bat or a ghost. I know, it's not a great shape. I'm sorry.
What's the ghost look like?
What's that?
What's the ghost look like?
Okay, that's what I thought. Yeah, go ahead. I'll go do the ghost.
I like the bat, so worst comes to worst.
Yeah. And I can show you guys how to do your own shapes eventually, just not tonight because it takes a while. So we'll go back up to import DXF. I'm going to go browse. So we'll go to ghost. Go ahead and open. And then for this one was, let's see, ghost config 0.01 I have. Let's try that. Not much better, huh?
I like the bat.
All right, we're going to do the bat.
You could have done the Snapchat ghost.
Look,
instead of
I was
that.
going to, but then I'm like...
That's what I was thinking.
People were going to make fun of me. All right, I'll do the Snapchat ghost really fast after we just get some components on this. We're going to do the bat because
The
you guys
bat
are
one's
so
cool.
freaking picky. All right. Okay, we're just going to select that all and delete it. Jeez, you guys are so mean sometimes. All right.
It looks fine.
Bat
I
is
just
good.
like the bat.
Yeah, I know. The bat is the coolest out of all of them. Did you
Yeah,
guys see
'cause
it
it's-
whenever I posted it?
It's like Batman, so you can really use it all year round.
True. What were you going to say, Amit?
No, I was just saying the bat is good. We're not dissing you.
Hey, that's why I named it Bat Good, because I liked it. That was the first one that I did, and then it just all went downhill from there. The leaf is also pretty cool, and you can get the leaf in red and yellow too, so it's kind of fall colors.
The leaf is cool.
Let me see, what was this one? 0.03. All right. Go ahead and run that. There we go.
It's like Batman.
Yeah.
It's like this little thing that you can throw.
Cancel. Also, if you want to move these, you're going to have to group them together. Just hit new group and do outline. Okay.
It was easier to move all the components near it.
Yeah. So actually, if you try to move a part of this outline, it's actually just a bunch of different little lines. So you'll end up moving just like one thing out of place. I don't know if you guys saw me do that. But now I'm going to give you guys a couple of minutes to arrange things on the board as you see fit. If you want to know what order the LEDs go in, you can see the D1, D2, D3, all the way up to D8. And I'm probably going to arrange mine a certain way. Is anybody having an issue importing this file to get the outline? Does anybody have questions? Anybody have shape requests? A better ghost. I can do that. All right, so I'm going to give you guys about 5 minutes to place components on here as you see fit. There is a rotate tool. By default, it'll rotate things by 90 degrees. If you want to rotate things by like 45 degrees, all you have to do is come up to rotate here, and you can type in the angle in this little box. So go ahead and just move stuff on, play around with it for a little bit, and then we'll start wiring it up in about 5 minutes.
Yo, do you guys think that it's kind of crazy that tomorrow's Friday already?
Yeah, it doesn't really feel like it.
Dude, I like just realized that. And I was like, no, like yesterday was Monday.
Yeah, it kind of flew by the week. Just kind of flew by.
Dude, like I feel like Monday, like the research night like just happened. Like, dude, I don't know.
Maybe
Everything
you'll get your sense of
blending
time
together
checked out.
these days. Oh, also, you might have seen me going through my little existential crisis there, but I finally finished my math problem. So
Congrats.
if that's not like a description of every math class you've ever had, then I don't know what is.
The good math classes get you through an existential crisis on every problem.
It was actually a pretty dumb mistake that I was making. It was like a whole thing about like proving that these two integrals were the same. And the mistake I was making is like, it was like G is equal to F inverse. And when I was doing a U substitution for one of the integrals, I was saying that U equals G of Y, which equals F inverse of X instead of F inverse of Y. And so then like
I think I know what you mean, yeah.
Down the line that would screw me up because then I would have to like integrate something with respect to like U, but it was like taking in Y, and it was just like a whole thing that was like really confusing, but I figured it out. So let's see if I can keep the momentum going with this GBZ80 program that I've been a Hello World program that is taking me like 3 days to program.
Yeah, I feel you. All right, I'm going to leave this up. I'll be back in just a second.
So how are you guys doing?
Okay. I just had my 432 exam before this. A little brutal.
Sorry, who's talking right now? I can't.
Me, Rebecca.
Oh, there. I'm on my
Yeah.
phone, so like
I
I
see.
can't see anybody. I can like scroll through people, but I can't see like.
Yeah.
Oh wow, there's a lot of people here.
Yeah.
That's cool. I didn't realize. I thought that it was just that first screen of people when I scrolled over. I didn't realize there was like how many people are here right now? Like 16?
14.
14. Okay. It's pretty solid.
That is.
All right. So does everybody have theirs laid out pretty nicely
Yes.
in an interesting way? I know there's not a lot of components, but that's kind of the point for tonight. Also, if you want to move stuff around with a little bit more precision, you can press and hold Alt while you're dragging it. I don't know if I said that earlier or not. Doing well. Everybody's having fun. Well, I'm going to take you guys to another interesting part of this. You'll notice that there are all of those little lines connecting these pieces together. Those are the trace indicators. So this is kind of what it's called actually a rat's nest configuration. And it just shows you kind of where things need to go in the end. So right now I'm going to show you guys how to start routing stuff. We're going to be routing this by hand to start with. But as time goes on, I think you might find that some of this, because it's a very simple circuit, compared to some other workshops and other PCBs that you might have seen before, we can auto route it a little bit later. But to start off, we're going to be using this route air wire tool. It's going to be off to the side. So we're going to come into something like this. And let's see. It's something easy to route. Let's do this. So this one over here, it'll say A and then N $12. So I just know that this goes to that right there. So you can kind of see that this line will kind of warp around things, loop around them until you get to the point where you want it to be. But at any given point, you can always just you can just stop it and then change the direction if you don't like the direction it's going. And you'll notice up here, you'll see that width of 10 that we had assigned before. Let me finish this trace up to there. There we go. So there's the first trace. You can do a ground to a ground or whatever you think is easiest right now. But these traces are on two different sides. So the red is going to be the top, blue is going to be the bottom. And you can switch between them using this layer tool. You only have top and bottom enabled right now because this is a 2-layer PCB. You can change that in settings, but for most things, 2-layer PCB is going to be just fine. So I'm going to stay on top. What's something else? Actually, this is a rather good one. So I'm going to, again, do top here. And here's my predicament. I need to go up, but I don't want to go the long way around. Let's say that we need this trace to be as short as possible, because we do actually need this to be as short as possible. So for right now, it's saying that I can't go through that. Well, we also have a bottom layer that we can use. Why don't we just utilize that? We can actually use this via over here, which is the tool you'll see. It has a red wire going into one side, blue wire coming out the other side. And that's exactly what we're going to do. So we're just going to place it right there. And you'll see that the trace goes straight into that. And then what we can do is we can go back to the route air wire tool. And we're going to select bottom. And we're going to click right on that point where it ended. And you can see that this is all one. It highlighted both of these. It highlighted the ground trace and it highlighted the little via there. So vias are essentially just holes that are filled with copper, go from one side of the board to the other. Any questions about that? Now, does anybody see anything wrong me doing what I'm doing right now.
I have a quick question.
Okay, what's your question?
Sorry. Like, so it doesn't like necessarily snap to where I want it. You know, like,
Okay.
so it's not snapping to overlap with where the wire is. So it's a way to like, you know what I'm saying?
Yeah, I think I have an idea of what you're saying. Are you trying to route something to the little microcontroller?
No, so like when I place that, start with a V, a little circle thing.
Okay, the VIA.
So like I click the little circle thing, yeah, to place it, but it doesn't actually like line up with the red wire that I have.
So what you can do is you can delete that wire and you can have the VIA there to start with and then just like drag it over to the VIA and snap it there. If it's not snapping, remember you can hold Alt for a little bit more precision.
Okay.
That might work a little bit better.
Going
Okay,
back
anybody
to-
who's not Rebecca, tell me what I'm doing wrong in what I'm trying to do here.
Geometry, 90 degrees.
That is correct. Does everybody else agree with the 90-degree is bad assessment? Okay, good. You're right. I actually didn't even notice it whenever I placed it down, but I went to go drag it up and I'm like, ah, crap. I'm doing exactly what I said not to do. So I'm going to go ahead and back that up. I'm actually going to drag the VIA kind of closer back here. And then I'm going to go ahead back up to top, which another thing to mention, these circles that you see on here are holes, which means you can start them either from the top or the bottom because they go through. The copper goes through. There are little rings on the top and bottom. So keep that in mind. But for this, I'm going to go ahead and go to my route air wire. We're on the top. Click and drag from there to, oh, hello.
Go. That's what I was
Ah,
talking about.
okay, so
Yes.
yes, I see exactly what you mean now.
Yeah, I did. I'm still stuck.
Oh, ignore obstacles. Let me try that. Yeah, that's what we want. Ignore obstacles. So I want it to go to that. I don't know why it's giving me an error though.
You
might
have
not
to be on the
clearing
bottom layer.
it. You might be too close.
I might be.
There's clearance is set.
So let's go ahead and delete that again. Again, the program definitely has its quirks. Give me 1 second because I have notes on this because I had the same issue happen. To fix the clearances, you can go back into that global settings that we had gone to before to change the trace thickness, but just give me 1 second. All right, so from what I said, what I wrote here, I mean, basically I just put down the trace first and then did the VIA, and that seems to work, so that's what we're gonna do. So we're gonna go ahead and make this trace on the top. Click it there. Click down a VIA. Those are connected now. And then we're gonna go back to the bottom and just route that up here. Gonna go ahead and go at a 45. There we go. And so you'll notice that whenever you click it there, it will end and you'll get a little ding from your computer. So you can go ahead and do that a couple of times. If you have questions, feel free to ask. I'm not going to do all of these because it is an art. Designing a PCB is definitely an art. It's not always clear cut. There are multiple ways to get a trace from one side of the board to another. You can also run traces underneath parts too. So I'm just going to continue this line kind of. So because this is not going to be above where the PCB layer is, you know, you're going to have a chip that's on top of it, soldered in. You can still run traces. You can run as many traces as you can get underneath there. This is a very tedious process. So for simple circuits like this, one may say, isn't there a better way? Can't I get, I don't know, an AI to design this for me? And yeah, Eagle has an AI for that. It's more of, well, not really an AI. It's more of just a program that it will find the best path, just selects an algorithm to route stuff. So again, in the interest of time, because we only have about 18 minutes left until I want to have this workshop over with, I'm going to go ahead and show you guys how to use the auto router. Hopefully you guys didn't get too far. And if you did get really far, you don't have to do this command, but if you type rip up into the command line at the top there, I don't know if you can see it on my computer, but there's a little place where you can type rip up. If you hit enter, it will ask you if you want to literally rip up everything. Let me go ahead. I don't know why it's not doing that, but it's whatever. Actually, I'm just going to do it manually. There's a little rip up tool. It's probably easiest. Again, if you have already gotten pretty far in this process, you do not have to do this at all. This is just me showing you another tool. Okay, I'm back at square one here. Is everybody following? Okay. Back at square one, and some of you might have already noticed this tool. It says auto router off to the side. I'm just going to click on that. It's going to ask you a few different things here, but you don't have to worry about them right now. The one thing you want to worry about is this effort. High effort is going to put in a lot of time and a lot of processing power to try to get this to where it is most efficient. I have a 16 thread desktop. It's going to do that in a matter of seconds. If you're on a laptop, good luck. I'm going to do medium because I think it's pretty standard and you're not going to have too many issues with this. I'm going to hit continue and start. And it's going to do its darndest. You'll see it's going to flicker a lot. To get these in a pretty good configuration. It looks like it's found one. So I want to inspect this first. It already knows that it's not supposed to take any 90-degree angles, but unfortunately it does. I'm going to click evaluate here. You can see that this ground signal wire here is definitely at a 90-degree angle. One of the ways that you can fix that is simply by selecting it somewhere, selecting it and going at a 90-degree angle, just kind of making a Y. And then there are other ways that you can alleviate those issues, but just it is best practice to avoid that. So, but for now, I'm just going to leave this as it is. Because we're using low voltages, it's not going to make that much of a difference. You'll see down here, though, that it's pretty darn close to these signals and stuff. Because this is a surface mount part, which means it does not go through all the way, it can only access the top layer to do its signals. It can still go to vias, and it can still link to other traces. And you'll see that actually this bottom layer, this VDD on the bottom, completely intersects to those, but because it's on the opposite side, you can do that. So yeah, the auto router tool is good for a lot of things, but it does not always produce the most accurate of results. It's not always kosher, especially whenever you get to much more complicated circuits and you get to very high frequencies. But for now, this is good. Any questions with the auto router tool? Any questions with routing these in general? This is your time to ask questions. Actually, you can ask any question you'd like about the PCB design process, because I do want to be bringing this to a close pretty soon. And I'll be sticking around if you guys have extended questions. But do you have any questions about the circuit? Do you have any questions about what the material is for the PCB, how this kind of works? Oh, so now everybody's an expert, huh? Everybody becomes an expert when I ask if there are questions. Honestly, if that's only how the world worked, just feel like the professor asks a question and nobody answers and everybody just knows. That'd be fantastic. Nobody has questions. All right, fine. We'll get to the competition part of this. So time to get competitive. Oh, you got a question?
Yeah.
Oh, hell yeah. Let's go. What's the question?
What's your favorite color?
Oh my gosh. I guess that's fair. I was mainly asking about, that what we're doing.
No, come on.
Cobalt blue.
Don't entertain my stupid question.
Look, I'll entertain it for the time being since nobody else would like to speak. Cobalt blue is my favorite color. Good. Okay. We can go around and share our favorite colors after this if you guys would like. I know everybody is completely free and they don't have anything else to do. So, yeah, there's going to be a little competitive aspect of this. So in a week from now, I'm going to be collecting all of the files that you guys design, if you want to see this project through to completion, of course. And the best design based on a couple of factors. So layout, if you would do something creative with the shape. If you add some more things onto the solder mask, which I'm going to show you here in just a second. The solder mask is kind of like the text on the top that you'll see. If you do anything special with that, those will all be considered, and the best submission, I will get 20, 30 copies of it, and we'll distribute it out to you guys. And if you want to build the circuit, I'll give you a parts list. I'll go ahead and provide a guide on how to program it, make it flash cool colors and all that. And I'll show you guys just generally how to build this yourselves. That's not going to be a workshop on its own, but I think it'd be interesting to see what you guys come up with. So it doesn't have to be Halloween themed. It doesn't have to be fall themed. I just thought that it'd be interesting to provide you guys with some cool shapes tonight. So with that being said, I'm going to be ending the main workshop content here. I'm going to be doing a little bit more of the generic design as far as, hey, I want to get some text onto this PCB. I want to, draw some indicators and stuff like that. I'll show you pretty quick how to add some pictures onto a PCB. So we can add the pictures of the pumpkins and the ghosts and the bats and all of that. I used a separate program to generate the images that we're going to be using, but for tonight it should be fine. So, does anybody have any wrapping up questions? If you have other stuff to get to, I understand. I've taken up about 2 hours of your time already. So, any closing questions? No? All right.
Oh, one quick thing, sorry.
Yeah, sure.
You said you were going to show us like how to design little shapes like this. Is it just choosing the line and drawing little lines together to make the shapes? Is that what you did?
Yeah, pretty much. So I'll go ahead and get back to that. I'll go ahead and exit out of this. So you'll see that there were also .svg files in this. It's DXF and SVG. It's a vector graphics format, and you can use like Photoshop or Illustrator to export those. There's a free program called Inkscape that I like, and it can turn any image, any black and white image, just into one of these vector images, so you can kind of just draw lines in here. But for example, I'll go ahead and I'll do, it's actually a ULP that I run, I believe. Let me go and see. Maybe it's up here. I don't know if I had provided it to you, but there is an import bitmap that you can use to import black and white pictures, and you can select, only the black to come through. But for this, it's just going to appear white. Let me go ahead and see. Eagle import SVG. Yeah, this is what I wanted. SVG to Polygon was the one. Unfortunately, I think there's another file that you have to download. I'll share this this link with you guys real quick. I'm gonna go ahead and stop sharing just for a quick second. So if you go ahead into this, there's gonna be a link there. And it's gonna be kind of pointing you towards a GitHub as well. And there's gonna be this thing called a ULP. I'm just gonna throw onto my desktop real quick. Hold on. Again, you can see why this was not main workshop content. It is significantly more difficult to get this running. But if you want to design and put on just like lettering, that's easy enough. But most people don't want to just do lettering. So I'm going to show you guys how to do something a little bit different. So that link that I posted is going to take you to a website. It's on the sparkfun.com thing. And then there's a section that says import SVG as Polygon and Eagle. And it says download the Eagle-ULP's repository as zip. So the Eagle ULP just takes you into this GitHub page, which I will also paste in the chat just in case you guys want a more efficient way of getting there. But this whole entire article, I followed it to get the images that we used for the outlines. And it's also what I've used in the past to get stuff onto boards. So like this one, I had like sponsored by RTD, and I had a few images on the front. And then somewhere around here, I have the Christmas ornament workshop PCB that people may be familiar with. That was a mess. But I'm going to go ahead and share my screen again. I see the smiles. Yep, people know what I'm talking about. Okay, I'm going to go ahead and open up Eagle. I'm going to go ahead into Run ULP, Browse. I had just thrown it onto my desktop, SVG to Poly. Yes, I'm an Among Us fan. And we want to go ahead back into this IEEE Workshop 3. Sorry for my internet cutting out, everybody. Let's go back into share screen. Can you guys hear me okay, by the way? Okay. Let's go ahead to batgood.svg. I'm going to put this on tplace. And for a scale factor, let's do 0.05. It may even be a little bit big for that. And we'll do an outline of 0.002. Hit OK. All right, it didn't draw, but maybe it's because I'm using a different file format. Anyway, you can import SVG files to draw them on here, or you can import the bitmaps, but that whole entire setup shows you how to do so. Let me get one that I know works, and then I'll be providing all this stuff in an email for a follow-up. So let me go ahead, SVG to Poly. Let's go ahead and browse. I think I had some more on my desktop. Maybe they were in the schematics. Well, here, let me just show you how I do this. I think that's probably easier when all is said and done. Let's go to this bat. It opens it up in this program called Inkscape. It's free. But then you can just do export or file, save as, and then plain SVG. Go ahead and just save it there. Go ahead and remove the front thing. Maybe because I saved it differently. Oh, thank you guys for coming, by the way. I understand people got to run. So yeah, I just saved it to that. Go ahead, close without saving. So there should be another bat good in here that I'm going to use. Go back to the board. We're going to try to run that ULP again. It's just a certain script, by the way. There, I just saw the chat. It's a certain script that's used. So let's try that. So 1, 1, 1. Okay. All right. For some reason, it's hating me tonight. But in the future, I will make a... yeah, thank you guys for attending, by the way. I'm going to make a guide so that I can follow this up and show you guys exactly what I mean by this. But yes, using that import function, there is a way to get these in here. I'm actually just going to try to import the DXF and see if maybe I can shrink it down even more. And I'm just going to put this on tnames. Go ahead and run that. Let's see what it does. Oh, here we go. It's a nice little shape. I'm just going to select this. Go to right click, add to, or new group. Call it bat1. Go down to this. We'll go ahead and move the group. And so then when you place it on here, this will actually appear on the same level, so the same layer as all of the placement icons, actually. So if I were to go into this manufacturing tab, you can see, it's really thin, but you can see that it generates a little bat right there. I can actually make this bigger. So this is a good representation of what it's going to be like whenever it is printed out.
Does it also show the back side of the silk screen?
Yeah, so you go down here, click bottom side,
Okay.
That's the bottom side of it. So this is what's actually going to show up whenever you get it ordered and printed.
And is it possible to inspect each layer separately? Not on here, but I guess maybe it might be on here too. But
Oh, yeah. So I believe it's in view in layer settings. So what I can do is I can turn off the top layer like that. Gets rid of all of the traces that are on the top layer. Same for the bottom. And you can change the colors of them, but this is a pretty standard color. The dimension you can get rid of, but you can still see the outline of it. T-place. So this placement actually is what shows up, but the T names will not show up. So actually I should have put that bat on the T-place because that one shows up. But yes, you can inspect everything separately if you would like.
all right, thank you, Ethan.
Mm-hmm. Any other questions? I know we still could just have a couple people in here.
Have a good night.
Oh, have a good night. I'll see you later.
That's good too, Ethan. Thank you, though.
Yeah,
It was a
of
good time.
course.
Have a good night.
See you guys.